Good evening, everybody. Welcome to Advanced Java Programming here at Portland State University. I'm David Whitlock. I'm the instructor for this course. I am super psyched about this term because I look out and I see so many of you. I've been teaching this course for a long time. I started back in 2000, back when I was much younger, much thinner, had a lot more hair. This building wasn't even here. As a matter of fact, kind of a funny thing, the first time I ever taught was in the building that was here before this. Some of you guys have maybe been around. Remember what the old building was like here? It was this like building built like in the 50s by the phone company, and it was like the most depressing utilitarian thing you've ever seen. It had like this blue tile on the outside, and on the inside it had this like neglected courtyard with all these really like gangly trees and everything like that, and the roof leaked and everything. It was awesome. So this building is much nicer. It's actually kind of nice for me to be back, and the reason I'm here is because there are so many of you. Normally I have like 20 or so people. We've had like more than double that express interest. And so I'm really excited about teaching all of you. And actually, I'm kind of curious to know why so many of you are here. We'll get more on that later. So let's see here. To get started, we'll be covering a couple of things tonight. There are handouts for if you like paper things. Tonight, I'll provide you with handouts. This is stuff like the syllabus, the first assignment, this thing called cones. It's all stuff that we'll cover tonight. Normally, going forward, I have all of the materials that you'll need up on the course web page, and there are some things you can do to prepare for class. So, like I said, I've been teaching this course for a long time, and it's evolved over the years. When I started out, there were a couple of handouts perhaps in the back. Are there any left? Got it, okay. When I started out, it was sort of like your traditional sage on the stage. Hey, I know a lot about Java. And I would sit here and talk for hours and hours about Java because that's what I like. And after doing that for a long time, I realized a couple of things. I can talk for a very long time without a break. And it was getting kind of boring for me, sort of the same thing year after year. And I was thinking, my God, if it's boring for me, how bad it must be for my students. So last year, I started an experiment where I recorded all of my lectures, so me talking to pieces of text up on the screen. I recorded all that, put it all up on YouTube, and I said, okay, if we do all of that, what can we do during class? And what I tried last year, and I thought it went really well, and what I tried again this year, is that we code. I code. You watch me code this week, next week, and probably some of the same thing, but after that, you'll be coding. We'll be coding together. So what I'd like you to do, prepare for class going forward, is watch the videos to give you sort of the background on whatever the topic is. So whether it's Java programming language or how to use tools like Maven and JUnit, stuff like that. Take your time to watch them outside of class. The nice thing about the videos is that you can rewind it when there's something that maybe I skipped over a little too fast or you couldn't understand what I was saying. Also, it allows us to then have a discussion in class about what it is that you learn, maybe something that you're struggling with in your assignment, or just something you'd like to know more about. Right. So, any questions before we start digging into things like the syllabus? Is everybody here for Advanced Java Programming? No one's like, oh, is this in French 103? Okay, good. Right on. Oh, and I guess another thing, you saw me start the recording. I record all the lectures. I do a screen capture of my laptop here, and I'll post all that stuff up to YouTube so that if there's something that I say during class that you want to review, or hey, it's a summer, maybe if you can't make it for a week or you get sick or whatever, you don't miss the thrilling experience that is CS 410J Advanced Java Programming here at Portland State. Okay. Actually, I introduced myself. We've got one other person to introduce. Dave, get up and introduce yourself.
Okay. My name is David. I'm going to be the TA this term.
What's your last name?
David Kennedy. I'm getting into the master's program here. So basically, I see my job as helping you guys. I took this class last term, and helping you guys with the assignments as much as possible. So yeah, I guess you'll get into this, but we have a Google group thing, and I guess the best way to contact me is through that. But any questions or anything about the assignments, great to help, and yeah.
Yeah, there's so many of you guys. I get a grader. I haven't had a grader in like 10 years. It's awesome. Because then that'll allow me to, allow both of us to focus on making sure that you guys are well supported and that we can get quick turnaround on your program assignments, things like that. Okay, So let's talk about what we'll be doing here. So actually, there you got this in paper if you want to read it close to. Otherwise, I'll direct your attention to the screen here. So why are we all here? Well, I hope you're here to learn about the Java programming platform, the language, the APIs, all the tools, how to develop software in Java, and I hope you have some fun doing it. I really enjoy writing code in Java. I know when I was in school and I first saw Java, it was a nice breath of fresh air compared to sort of the C, C++ stuff that I was doing, all of the pointers and all that stuff. Java doesn't have that. It's got a lot of nice features to it. So how are we going to do it? Well, there's what we're doing tonight. There's talking in class. There's also the online lectures, like I mentioned, and also pair work. And so over the next couple of weeks, we're talking about what it means to pair program, and we'll be going through some what are called code katas, which are little exercises to help you guys learn how to program in Java. Outside of class, you'll be seeing a lot of examples, motivating examples. I hope that they motivate you to write some good code. I believe in sort of teaching by example and learning by doing. That's why, for me, it was like put the lectures up online so you guys can watch those in your own time, and so that while we're all here together, we can work together. And I hope that you'll learn Java not by reading a book, but by writing Java code. One of the ways you'll do that is through a multi-phase project. So there is a 5-part project that you'll be doing over the course of the term. You'll get the first assignment tonight, and each assignment builds on the last. And this is purposeful so that you understand by the time you get to week 5 or 6, there may be decisions that you made in week 1 that you might want to go and revisit. This is just the way that software is developed, and I wanted to give you guys as realistic an experience with it as possible. And there are also quizzes and exams. The quizzes are online. Here again, I don't want to take class time to have you guys sit here and fill out some piece of paper under the pressure of the lights and everything like that. Good to assess yourself at home. And then there are also, yes, there will be a final exam. It's not really a midterm. So what are we going to talk about? Well, or rather, what are we going to have a chance to learn about? First, there's the Java language syntax. So Java's been around for a while. The language has grown quite a bit since its inception. There's a lot of powerful things you can do with it. We'll also be learning a lot about object-oriented design and programming. You guys have taken C++, right? So you've seen objects and methods and functions and all that good stuff. Java has its own way of representing that stuff. And I think one of the things that I really like about it is that it's got a standard API, an application programming interface, that embodies a lot of good object-oriented principles and practices. So you get a good experience working with good objects and some not so good objects, and we'll talk about that. And here again, those standard objects are used to do things like group other objects together, give you I/O, do date formatting, all kind of stuff like that. That's all in the lecture material. It occurred to me a couple of years ago that Java, the programming language, isn't like the cool programming language anymore. It's not the new hotness. But there's and just learning Java itself isn't enough to get you by. One of the things that's really been occurring to me over the last couple of years is the importance of software craftsmanship. So yeah, you can get out of here and the language, but you necessarily know how to build good code. And I wanted to integrate that into the learning experience here in Advanced Java. And so starting tonight, we'll be looking at how you develop good automated tests for Java programming through unit testing. We'll be seeing a good video, and then I'll be demonstrating test-driven development. And we'll also learn about a tool called Maven, which is for building projects. So you guys probably, how many of you have done a little bit of Java programming before? Hopefully everybody, right? Sort of in the 200 series someplace. You probably learned about, here's the command line for the Java compiler. Maybe you're using an IDE like Eclipse or IntelliJ or something like that. And you know that there are various phases to building a project. You compile everything, and then maybe you learn about jar files, and then running it in the VM. And there's a good amount of overhead there. Well, Maven is all about streamlining all of those steps into something where you can focus on writing your program instead of figuring out how to build your program. In the second half of the course, we'll look at developing web applications. And so, it's only an 11-week course, and I don't have time to go into the details of HTML and JavaScript and things like that. So what we instead focus on is sort of the fundamentals of the web. We'll look at the HTTP protocol. We'll look at how something called Java servlets, which is a way of handling HTTP requests in Java. We'll look at something called REST, representational state transfer, which is for basically providing a web-based API for your application. So we'll get a little bit of web stuff. And then we cover topics, more advanced topics in Java, like reflection, doing some metaprogramming, and then dependency injection, which is a pattern for decoupling the objects within your system nicely so they can be tested independently and so they can be reasoned about independently. And finally, I like to introduce a graphical user interface technology in this class. One of the nice things about Java is that it's always had a very user focus. And the technology that I'm using right now is something called Google Web Toolkit, which allows you to write Java code, which is then translated into a web application. Translated into JavaScript, and you run it inside your browser. And the nice thing about this, and I think why it works well for this class, that first of all, well, it's Java code, you've been learning Java. There are some really interesting programming patterns that Google Web Toolkit follows that I think will help reinforce things earlier in the course. And allows you to write a very reactive, slick web front end to your application without having to know a lot of HTML or JavaScript or CSS. So those are kinds of the things that will be covered. Are there other topics that people would like to cover, or you're like, oh, I want to learn about X in here, and it's not advanced enough? Anything? No? Okay. This is my Bueller. Oh, God, you guys get that reference, right? Okay. I'm old. Okay.
Will we do any Android-specific projects or anything to that sense?
No, I don't have anything Android, although there's a lot of things in GWT that, like the, what are they called? Not actions. There's the, there's some concepts that are similar to the way that Android is developed. I don't have anything Android-specific.
I asked a Java dev, and mostly Maven's been succeeded by Gradle. Do you know anything about that?
I do, okay. And yeah, so Gradle is another build technology that has some pluses and minuses to Maven. It's funny, at work we use Gradle, and there are lots of Gradle components. Here I find Maven works well for the course, and the material's already written, all that good stuff. But yeah, so you'll get a good introduction to Maven. And actually, have you experienced? You worked with Gradle? Okay. Well, if anyone has and would like to, talk about a, sort of do a comparison, and maybe that'd be something I'd be completely open to. Gradle Smackdown, get Hans Doctor up here. Anyway, blah, blah, blah. Okay. So, how is your grade determined? The bulk of your grade will be determined by the projects. What we do in here is we write code. We don't write sentences about code, although we do some of that. We write code. And so here again, it's a 5-phase project, plus there's an assignment for the Java cones that you build up over your entire term. So that's 60% of your grade right there. There are also 8 quizzes, and I think the first one opens tonight and is due next week. Is each worth 4%, and I dropped the lowest quiz grade. And all those are delivered using D2L. There, I think, I can never tell with D2L, man, that thing's so hard to use. Yes, there are time limits, and I guess I'll say that I've never had anybody complain about the time limit, so I think they're reasonable. Let me know. I think it's like 20 minutes or a half an hour or something like that. But if you find yourself, it's like, oh, well, it's quiz 3 and I don't, I haven't had enough time to do them all, let me know. I want to make sure that you guys, have enough time to successfully do that. And then the final exam is worth 12%. And so then, looking at that, I recommend that you put the bulk of your effort into the projects and getting them really solid and really working well. And then, don't sweat it too much over the final exam because it's probably not going to help your grade if it's bad anyway. Any questions?
So
Okay.
with 8 quizzes in 8 weeks, and the 8th week being the final exam?
How does that work?
That's fine.
8 quizzes in 8 weeks. Yeah, I think there's 1 week, and 2 of those are, one of those is a survey. 2 of those is a survey. So I think there's one where you might have like a survey and a quiz the same week. If you log into D2L, I think they're all on the calendar.
Okay. So basically, week 1 through week 7, there will be quizzes, and then week 8 will be the final.
Yeah, something like that.
I just tried to log on to D12 on my phone and I wasn't seeing the class yet.
Oh no. Okay. Do I activate it?
Yeah, you have to activate it every time.
Okay. Can you activate it?
Maybe. Yeah.
What do I pay you for? Activate the class. I don't know. Okay. I said you pay him. Yeah, what do you pay him for? Right. You pay me too. Anyway. Yeah, if you could look into that. This is awesome. My car's a little dirty. Can you watch how it works? Okay. So, and all the project due dates are up on the website. They're also, if you turn in your hymnal to page 2, every assignment also has a due date up on the top. They come fast and furious. So you'll notice that obviously there's nothing due this week. You get the first week to do to start on the koans and to work on project 1, but then after that there's a project due every week, and they're incremental. So I mean, it's experience has shown that it can be done, but also experience has shown is that if people fall behind, it can be hard for them to catch up. And so to that end, you have 2 late days because hey, life happens, or right before submission you realize that you have that fatal bug that's going to take you 2 hours to debug. I totally understand. And so you've got 2 days to use anytime during the term for late projects. And you can also, I'll let you resubmit 1 project for regrading within a week after getting your grade, because maybe you misunderstood something about the project assignment, or you thought the command line should be parsed one way and it was parsed another. Hey, I understand. Otherwise, don't be late. Please keep up, and it shouldn't be a problem. Any questions about your grade? It's gonna be awesome. Yeah.
How will the grading be done? Will it be analysis of the functionality, or are you looking for code style, or all of the above?
Good question. So all of the assignments except for the last one, which is the GUI, which is the GBT assignment, are graded. I have an automated process that runs scripts for all command line applications. So I feed your program, hey, here's a command line, and I sort of look at he looks at the output and determines whether or not it's correct. So the vast majority of your grade is did it do something reasonable? Did it do what the project said it would? There is, and I'll talk about it next week. There are some requirements in terms of how your code is documented. So there's something in Java called JavaDoc, which allows you to put special comments before things like classes or methods or whatever, and I extract that. I expect there to be some documentation in your code. Otherwise, I don't look at your code. As a matter of fact, I don't want to take the time to look at your code. I suppose if you ask me, I could. But no, that's not really part of your grade, because that's really subjective and hard for me to assess, especially with, oh my God, there's so many of you. Right. Yeah, but what is it? You get, it's like
2 hours per student
for the entire term, right? So it's like Warren was saying, the enrollment was 44, and so that's 88 hours, which is 8 hours per week. And look at him, he's tired. So this is awesome. I never had a sidekick before. You get correct, sir. Anyway. Some of you even got that. Awesome. All my jokes are from the 80s. Okay. Where were we on this? Oh yeah. So I don't want to have to look at your code. And so, for instance, when you submit something, make sure it compiles, because whereas normally it's just hey, run the scripts, look at the output, yay, A+. If it's oh crap, it doesn't compile, I don't want David to have to look in and then figure out what's wrong or whatever. So yeah, that's kind of how I grade. It's about that frantic. Okay. I don't know why I have to tell you this, because it's really not a problem, but don't cheat. Gosh, I've had very little cheating, but it's I don't want anybody bringing in their lawyer, you never said I couldn't cheat, so don't cheat. We'll catch you, we'll give you an F, we'll call your mom and say you're a bad person. I don't know where you're going. We actually, there's this cool tool called Moss that we use to, any more handouts for this dude? Okay. There's a tool called Moss that we use to detect plagiarism. It's smarter than you are, so just don't do it. So, like, the official department line is like, it is cheating to submit for credit work that you did not create or allow your work to be submitted as the work of another student. I take, like, my personal policy is talk all you want. I encourage collaboration. I encourage talking, going back and forth, drawing pictures on a whiteboard, sketching things out. Maybe the occasional over the shoulder, oh, hey, that code doesn't look so good right there, but don't like take someone else's code. Don't like, maybe you've got a photographic memory or you're like a cyborg or something, don't look. So it's usually not a problem. But I don't want you to walk out here thinking it's like, oh, I got to work by myself. No, I want you to work by yourself. And certainly in class, when we do the pair programming, you'll be working with other people. I think it's a very important skill to have and one I want you to practice here in class. But when it comes to your projects, don't code each other's code. Okay. Other stuff, whole list of miscellany. Lecture notes, they're linked on the website. They're what I talk to on the screencasts. I think you need to have them with you in class. Let's see here. I mean, most of you guys have laptops, or I encourage you to bring your laptop. I also encourage you to pay attention. I know that there's the Facebook and all that. You're adults, figure it out. So if you want to sing along in class, please feel free to do so. I don't believe I have to tell you, but I feel like I should. Don't wait until the last minute to start the project. I've gotten a lot of feedback over the years, and one of them is like, hey, I read the project assignment. It might seem kind of easy, but oh yeah, there was some complexity there. There were some subtleties. So don't wait until the last minute. As a matter of fact, we'll learn next week that I've got a way to sort of force you into starting it a couple days before it's due. Document your code as you write it. So being able to express your intent of what your program does is important. And so I say, if you can say it in English, you can say it in Java. And I guess the converse is also true. If you can't say it, if you can't explain what you need to do, your program is probably going to be wrong. And actually, one of the things that we'll see in test-driven development is that when you take a test first approach, when you start out saying, well, what should my program do, or how do I want to start with something that I think is right, and I'll watch it fail, and I'll make it work, and I'll make it better. I was like, oh, okay, I've done the right thing. I understand what I've done. That's a really powerful way to develop, and it results in much higher quality code. And I speak from experience. Then when I sort of, had the problem half solved in my head and say, I know what to do, and I write a whole bunch of code, and I don't know whether or not it's really, really right. There's no shame in asking questions, right? We're all, you're paying good money to sit here. Well, you're listening to me talk now, but you're getting access to people like me and Dave who have know this stuff, know it well. And if there's something that you're unsure about, or something that maybe you read outside of class, speak up. You can speak up here. We'll also talk about the Google Plus community. This is send me an email. Don't sit there and suffer in silence, because most likely you're not the only person that understood. That has a question that needs to get answered. This is a senior level course. It's a 400 series. I don't know what your schedule is like this summer, but if you're taking like other tough courses, especially ones with a lot of coding, you might want to reevaluate your schedule. That being said, don't leave because we get less of him. Anyway, no, seriously though, I want you to be successful in everything you're doing, and this course is offered every summer, knock on wood, or whatever that thing's made out of, so make sure to do the thing that's right for you. I have lots of code up there, on my website. We'll see it's in GitHub also. Go play with it. Fork it off and make a copy of it. I'm sorry, you probably might not know what forking a repository is. Anyway, play with it. Experiment with it. Get into the debugger, stuff like that. My office hours, I probably have like some little office in a dark corner of the computer science department. I don't know where it is. My office hours are the hour before class over at Hot Lips Pizza. I'm sitting there eating, and it's a good time for you guys to stop by and ask me some questions. I'm also available on the internets through email and of course the Google Plus community. So I find the Google suite of tools to be very easy to use, works on a lot of devices. It's what the university recommends as far as Gmail and the calendar and things like that. And so I use Google Plus to sort of like broadcast out to you guys. It's easier to sign up for than like the listserv and all that other stuff. And so I've created a Google community. Here's the link to it. There's also an active hyperlink here on the class homepage. There's like this little badge thing right here. It's also over here on the left. Please sign up. I've already posted a couple things on there. But as I like when grades for a project are available, or hey, Dave's sick, we're canceling class, and you guys can go party or whatever. That's how I'll let you know. And also I do have an email address. There it is, and of course the class webpage. And so then all the information for the term is up there. So that's lots about me, and I want to learn some stuff about you. And one way that I gather this is by asking you to to run a program that asks you a couple questions like your name and like what your major is and stuff like that. And what it does is it takes that input, creates a little XML file, emails it off to the grader's the grader account. And then what I use is I take that XML file and import it into my little grading program that I wrote a million years ago, and that's how you keep track of your grades. So please, either now or when you get home, log on to one of the CS machines and run this command line. You need to be sure to be running Java 8, and that will ask you the little survey and then send the email off to me. I think that's it. So any other questions about the class, about how we run it, about how it's structured? Any hopes and dreams that you have that aren't fulfilled by this syllabus? Yes?
So what is how heavily will we be using IE? I have nothing against IE.
Mm-hmm.
I guess they're not very friendly with SSH into boxes with command line only options.
Right. So the question is, how heavily will we use IDEs? And wait a second, if you're going to be grading all of our stuff on some Solaris machine running on a pizza box from 1993, how is this going to work? So I'm an increasing fan of IDEs. When I first started doing this, it was like Emacs, so awesome. You don't need syntax highlighting, and now it's like, wow. I've been migrating some of my code to Java 8, and the IDE makes it really, really easy. So what you're going to see in like me when I program in class, it's through the IDE. However, when I grade your course, when I grade your submissions, your project submissions, it's going to be online. So what I recommend, what's worked well for students in the past, is that you develop everything on your local machine. Now, this is Java, so it will is the run once, debug everywhere. Run once, or write once, run everywhere. Which for the command line stuff works. Over the years, students have developed on their own personal machine. You can also develop on the CS machines if you don't have your own machine that you want to use. You just have to use their environment, so text-based editor and the command line tools, install Maven, things like that. Did that answer your question?
Kind of. I was just curious, if they're IE specific, plugins or tools that you would really need.
No. What you'll see, my IDE of preference is IntelliJ IDEA, and they have a community. Oh, that reminds me. They have a community version, and I'm sorry. Well, you can download the professional version. You get a 30-day trial, and I also have an academic license that I'll share with you on the Google Plus. That will give you, I think, until December 25th or something like that. Really nice IDE, very fast, very responsive. You're also free to use whatever IDE you want. If you're a fan of NetBeans or Eclipse, you can use those too. I'm not as familiar with those, so if you have a question, I won't be able to help you as much. I don't know about Dave, do you have a preferred IDE?
I use Eclipse, IntelliJ. I like IntelliJ a lot, though.
Yeah, IntelliJ's really nice. Anyway, so yeah, nothing required. This isn't a course in using the IDE, but the IDE will help you in the course. It'll help you learn Java. Good question. Anybody else? Yeah.
You talked about cheating and stuff. I was wondering, can we use licensed code?
Can you use licensed code?
That would be
Yeah.
Okay.
Well, there will be. Let's see here. There are some third-party libraries that you can use, but the JDK has like everything you'll need, and also I'd be really surprised if there was any like licensed code out there on the internet that you like cut and paste into here. If someone else has written like an airline application that does exactly what this one does, that's probably or I guess I'll say in the past I haven't encountered really much of any. I haven't had any other students that have said, "Oh, okay, I want to use licensed code for this." I think one guy wanted to use like an XML parser for something, and I said, "Oh, wait, there's standard stuff. Go use that instead. It'll be easier for me." Okay, cool, good question. Okay, so that's the syllabus. 6:01. That was a half hour. The next thing I want to do is I want to talk about test-driven development. So, how many of you have heard of unit testing? Oh wow, look at all you guys. Lots of people. Where did you hear about it? What context?
162.
Okay, 162. So, what did you learn about unit testing? Can someone tell me what unit testing is all about? No?
Basically, it's to test certain functionalities within a program, like to verify that it works correctly.
Yep.
Yeah, it's essentially you're testing if all the little bits and pieces work well on their own, as opposed to seeing if the whole thing as a lump works.
Yeah, that's a unit in unit testing. You're testing small units of your program. And what you're testing isn't necessarily like what the end user does. So if you're writing, an application for your iPhone, you're not going to be, touching the widgets and things like that. Instead, you're testing the internals. And so as you're developing your application, as you're writing your code, these unit tests tell you whether or not you've done the right thing. Really over the last 15 years or so, there's been just a general acknowledgement that unit testing is a really good thing. What are some of the reasons that we want to write unit tests? What are they good for?
Catch bugs.
Catch bugs. Yep.
When you change stuff in the future, you know that you don't break something.
That's right. It gives you confidence that you can change things without and know if you've broken something. So if you've codified the logic of your program in these unit tests, it allows you to go through and re-implement things. Maybe try a different algorithm. Maybe try a faster data structure. Things like that. So all these unit tests are really good. And one of the disciplines that emerged out of unit testing is something called test-driven development, where you write your tests first. Or rather, when you think about developing a piece of software, what you start with is a test that fails. And so it's like you haven't implemented it yet, right? So you start write your test, and you run it, and sure enough, it fails because it hasn't been implemented. Maybe you get like a null pointer exception or a divide by zero or something like that. And then then your job is to make it pass. And once you make it pass, you make a little. Then you have an opportunity to go back and make the code better. In a process called refactoring. You guys heard the word refactoring before? Yeah, some of you guys. Okay, good. And there's this guy named Bob Martin. He's a rather well-known software. Oops, make it big. Software developer guru guy. And actually, he's got this. I'll show his website. He's got a really. I can't talk and. What is it? Encoder videos. He's got this series of what are called clean code videos. So Bob Martin's a big name in the software craftsmanship movement, and he's written this book called Clean Code. And it's a really good book. I recommend that you pick it up because he talks about how to write code that's for the long run. He talks about how to structure your code, low-level things like how to name methods and variables in a way so that the next person who reads your code understands. Especially when the next person is you. Right? Have you ever done that where it's like you've written some code and then you come back to it after a couple weeks, couple days, whole months, and it's like, oh wow, who's the idiot that wrote this? Oh, it was me. Oops. This is just like a professionalism thing, right? I mean, I've written lots of bad code. Anyway, these are, let's see, I guess the first one is super cheap, but the other ones are a little bit more expensive. And they're kind of cutesy, they're kind of cheesy in places. But I recommend this as like, maybe instead of like, your Aunt in Nebraska knitting you a sweater or something, you say, hey, can you buy me like this for the holiday? And as something that I think will really help get you in the mindset to write good code. Anyway, a little plug for Uncle Bob. I have here a 5-minute clip from one of his videos where he talks about test-driven development. And he's just sort of set the stage. He's building an application that models a bowling game and how you compute your score in bowling. And he's wearing this dumb hat. But the dumb hat has a reason. It's got 3 different colors on it that represent this red, green, and refactoring phase that you go through. So I want to take a couple minutes. Let me make sure that the sound is working. Turn it up. Okay. So I think he does a good job of sort of explaining what this test-driven development stuff's all about.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. Fade to black. Happy coding. Perhaps a non-native English speaker. So that, in a nutshell, that's a 5-minute overview of test-driven development. And so what are some of the things that you noticed that he did in that video? Yeah.
Follow KISS like a religion. Keep it simple, stupid.
Oh, not like the face paint and the star and everything like that.
Thankfully not.
Okay. Actually, he probably does dress up like KISS in one of his videos. But yes, the KISS principle, keep it simple, stupid. Right, baby steps. And this is something that it took me a little while to get used to, where it's like, it's okay to make very, very, very small progress, because that adds up as long as it's very stable at the end. What else did you notice?
Starts with the test.
Yep, starts with the test. So, right, and so instead of saying, okay, I want to have a bowling, so I got to write a game class, and here are all the methods in the game class, he let it emerge from the test cases. And so, right, I mean, what was he asking himself? Well, what happens when I do this? Or what's the simplest thing that my application can do? Again, starting with baby steps, starting with the very simplest thing, making sure that that's implemented correctly, making sure you have a test to verify that it's still implemented correctly as you go on. Cool. Anything else that you guys noticed? Did you notice how much he leveraged his tools? Back to the IDE question, right? So he wasn't like fighting against his IDE. He was letting his IDE tell him what wasn't compiling. When he realized that he had that duplicate code, he used the refactoring capabilities of the UI. So he wasn't hung up about letting the tools help him. That's another thing that I had to sort of get over, where it's like, no, I know how to indent everything. I'm gonna use VI, which has its place. But boy, the IDE, when you get a tool that helps you, it lets you focus on the things important, which is writing your application, not on the mechanics of the language. Okay, cool. Well, we've been at this for 45 minutes. I think I'm ready for a little break. How about you guys? Okay, quick break. Let's say 10 minutes, and so we'll be back when the big hand is on the 5.
I found the instructions for activating it looks like it's inactive.